Hi there, how are you today? Thank you for dropping by to my channel and enjoy your stay. Basically, I got the board right now. The name of the board is a TPA3251 stereo, and I believe this is a standard product that is coming out from the factory in a mass production level. So if you are asking what is my plan, I have three items for them to evaluate it. The first one is about the sound quality. That is why I have here a setup already on the sound quality. The second one will gonna be the parametric test or the electrical performance test. And the third one will gonna be a kind of a teardown test. That teardown test just to take a look at what's about the quality of the components, the soldering, whether there is a problem on the spacing, and so on and so forth. When I received the board, I tried to convince myself that this board was actually tested before it's sent to me, because it's already complete product in a PCBA level. Normally in a manufacturing environment, you should be able to see like QA pass or QC pass, that kind of mark that they put in there, which suggests that this board is actually tested. I just can't find that one in the board. But anyway, that's the reality of e-commerce, and that's the reason why I have to change the process. I started with the process to check immediately about this sound. Like I use this small speaker in here connected to the left channel, and supply the 16 volts, power it on, and listen to it. There is no abnormal. Okay, fine, the board is working. And then I set it up right here with the standard speaker that I have it in the right channel, and the other one in here is on the left channel. I drive it using a tube preamp. Let's put that one a little bit of volume. Alright, so the only thing that I can notice immediately is that even with this tube preamplifier, which comes with the volume control, that when I'm just this way, about 12 inch maybe, I can hear that there are more of like a white noise, like shh, like that. The white noise I'm talking about is that when you are tuning your FM radio, and then when it is out of tune, and that kind of hissing sound, that is the one that I'm referring to, which is can actually hear it in here, you know. That's the first impression, but when you are like 1 meter or more down, then it's okay. So I think this is gonna be a simple video actually, but before I'm going to continue it, first thing first, take a break, have a zip on the water, just zip by zip. Speaking of the board, it's just arrived actually by ZDO. You get the TPA3255, which is still in its package. Let's see if there is any QA marking. No QA marking immediately. What about the other one? This must be the TPA3250. Any QA mark, QA pass strings. So it's actually lucky today. This will going to make me visit tonight the TPA3255, the big brother. This is the TPA3250, the little brother, and the other one here, which is actually having under test right now, the UUT unit under test, is the TPA3251. That is the middle brother. These are actually the brothers from the same bloodline. I love that one. After that, when I'm finished with this one, I'm going to set it up right here, and I'm going to do this kind of performance test, electrical performance test, or that sometimes I call it as a parametric test, where I'm going to check the offset voltage for the left and the right channel, the stereo separation, the signal to noise, the initial power output at the 4 ohms load, and then I'm going to do a kind of a shock test as well. And then after it's getting a little bit warm or getting a little bit hot, then I'm going to perform the what's called the maximum power output after that shock test. And my reference in performing the maximum power output is the FTC, the Federal Trade Commission. That is a Title 16, Part 432. And of course, it's not 100% compliant to that requirement, but I'm just following about this what's called precondition that I need to shock test this TPA3251 into a 60 minutes shock test, both channel driven at 4 ohms, and I'm going to drive that into its about 1/3 of its maximum power for 60 minutes, and after 60 minutes I'm going to get its maximum power output. Well, that's something that in reference again to FTC Title 16 Part 432, that we're gonna be making use of a sine wave signal, and I'm going to take the reading in 1% distortion and 10% distortion. Have a sip again on the water. You too guys, I really suggest this one to have enough water. I already set up the parametric test for the electrical performance, but before I'm going to start it, I would like to say something about it, especially on the grounding system, because I am dealing right now with a BTL output. There is a bipolar tie load, which is a different configuration compared to the SE mode, which is the single-ended. It means to say by BTL that the left channel speaker terminal is floating, there is no ground, and also for the right channel is floating, there is no ground. As I inform you that I'm going to make the electrical performance of the video to make this video compressed and not so long, but I'm going to publish my report based on the generated DSO 2820E from the multi-instrument from Vertins and the QA401 from Quantasylum. I combined this PC-based captured into a one report and provided to you for checking as a shareware and courseware the performance of the TPA3251 from my setup, and that would be a better, I think, rather than showing to you the same process, the same method that I have been doing and showing to you in my Discovering the Class D Power Amplifier TDA8920 VTH in my earlier videos. There is an interface for the mute where you can check what is the standby or the deep sleep mode power of the chipset, and that's really good when you're trying to control it using a microcontroller. That's a plus for the board, but I'm a little bit sad actually because there is no interface for the clipping, the fold, which is quite necessary for a DIYers like me who like to interface. Hang on, I'll show you. Like the one that we designed is all are plug and play actually. This one is for microcontroller interface. This one is for the speaker, and this one is for the power supply, so it is really plug and play. Basically guys, I already installed the TPA3255 in here. That's the big brother, and the middle brother, the TPA3251, is under test right now for the teardown test. And I'm just looking at the computer right now, which is where I can see a clearer view of the surface mount device, or the SMD, which is run on a SMT processing area. And the way I'm going to describe it is that it's not from me or from my experience, but I'm going to refer that to a kind of standard that is being used in a real manufacturing environment, and that is IPCA 610, which is the acceptability of electronics component. Sometimes they call it the ANSI IPCA 610. ANSI is the American National Standard Institute, and the IPC is the Institute of Interconnecting Packaging of Electronic Circuits. We will not go into discuss the IPC in details. I just have to mention that one because many of my fellow reviewers and YouTubers failed to mention how they're going to put a criteria on how the SMD was assembled. Let my fellow DIYers and those guys who don't know about it and take a look at the IPC A610. And if you have that kind of knowledge on the IPC, then you can level up your DIY and your technical know-how on the acceptability of electronic assemblies. I would say that it runs under a controlled environment by taking a look at how the solderability of the components, especially the main chipset, the TPA3251 IC. And we can see also here the SMD components, like the IC, the 8 pins IC in here, the resistors, capacitors, the decoupling capacitors, the 104, which is 0.1. Based from the microcapture of the camera, we can see that it is acceptable based on certain criteria, again on the IPC 610. And if you look at the back, you can see that there is no manual soldering. This must have been go through a kind of solder wave, and you can see how the component was cut. They are equal, so this board did not process into a manual cutting. I can immediately see that one, and it looks like that I can only see one retouch in here at the bottom of the IC. You can see that there is a residual of the flux, the solder, and that's the only point that I can see that this is where a retouch by an operator's happened. The rest, it's all done by machine. I think $1,000 question is that is this board was processed in a standard manufacturing environment? Personally speaking, it's hard to say about that. What I can only say is that this board was processed in a large quantity, in a mass production level, and it is processed in a controlled environment. The way I look at it, it goes into a standard SMT machine. When I say SMT machine, that could be a standard large manufacturing or medium manufacturing, or could be even a tabletop SMT, and that so-called backyard manufacturing, if you are familiar with it. But it's not done manually. You know, with the advent of this so-called tabletop SMT machine, the pick and place, and then we got a reflow. You can have that already in a portable one, just like the same thing as what we know as the 3D printer. Before, you cannot have a 3D output, you need to go to the factory. But with the advance of technology right now, we can have our tabletop pick and place and also reflow. Those machines are basically up to the standard of IPCA 610, and that's the reason why it's hard to determine whether this board goes into a standard SMT environment or just that so-called in-house with up to standard SMT machine and reflow. Regarding the design and how the component placed, I know that this decoupling capacitors in here is basically required by the design to be put as close as possible to the chipset, the TPA3251, and this will give a little concern on the heat dissipation, because the heat sink is just put it right here. It's very close, and the way I observe it is the heatsink can goes up to 70 degrees centigrade with both channel driven at about 30 watt of power, and this may affect the decoupling capacitors in here. But that is a design requirement, so a compromise of the designer of this board between where to place it against the heat dissipation as probably is the best in here. Another thing for me just to mention about it is that it looks like that they go to a kind of a design review, that how they interface the heatsink into the PCB is that they put a fixed point in here, and then they left the other point to be adjusted so you can put the heatsink with ease. And in any case, there is a kind of variation on the heatsink, and that's something that is a kind of design consideration. The way I look at the trace is that they're following the recommendation from Texas Instrument on how you're going to design the TPA3251 in terms of PCB. And the other point that I'm going to say is that is to understand about the chemical used in the processing. Did they clean it? The solder is a lead free or not? Well, in case of this board, it's hard to tell the solder paste they're using. So why I mentioned about the lead free is that, well, according to the directives that a lead is basically restricted and hazardous substances, so that will have a kind of effect on human users like me as a DIYers, especially that this board is just a PCB level and expose it, so I can touch it, probably I can rub the eyes, go to the other things, and I get some kind of effect. So probably since we do not know that the solder paste that they have used is a lead free or not, it's always been a kind of protocol to wash the hands before touching sensitive parts of the body, like the eyes, the ears, the mouth, or the nose. Well, I just mentioned about that one because it's quite important that being DIYers, we should be responsible in our health, and that kind of hazardous substances that they've been using in our DIY boards. And not to mention also about the kind of chemicals that they use, like cleaning. You know, I can see in here when you touch it, it's a little bit sticky, and I can see some kind of residual in here. So those are the kinds of things that we need to understand when we are buying the boards. When we are buying the boards, we don't know how they process it. We did not do it in our own power of our fingertips. We don't know exactly what chemicals they are using, so on and so forth. Well, there's a lot of things to understand, guys, about the manufacturing, how board assemblies, like the standard, the IPCA 610. We talk also about the FTC Title 16, Part 432, and so on and so forth. But the reality is that I have to end this video right now, and I do it in a series by series along with the TPA3255, the big brother, and another one is the TPA3250, the small brothers. So watch out every episodes of my videos on the TPA325 series, the Pure Path Ultra HD Class D Power Amplifier. It's Ferdinand Dandy once again saying goodbye for now. Stay tuned, don't forget to subscribe, and see you in the next video. It's just about 40 degrees centigrade at the surface of the heatsink. and that will be like about 1 watt of power. That is just voltage swing at the left and the right resistive 8 ohms load.